Okay, right. So we now, if you can remember, we even calculated, like, but what did we do? I'll just revise it to you very quickly. We actually took HCl, right? We actually took HCl with a volume of 50 centimeter cubes, which had a concentration of 2 moles per decimeter cube. All right, and then we took NaOH, NaOH with a volume of 50 centimeter cubes, and then it was also concentrate. It also had a concentration of 2 moles per decimeter cube, right? And then we reacted them together. That's what we simply did. Okay. So during the reaction, as you all know, like it's an acid-base reaction, right? HCl is an acid and NaOH is a base. So when they both react together, a neutralization reaction is going to be performed, and then heat has to evolve out, right? Heat has to be released to the external environment. So it's supposed to be an exothermic reaction. We experienced it when we did the calculation with the reaction. We observed 4,200 joules of energy was lost to the outside environment. Okay, that's what we simply observed. Right, then we have to talk a little more things about this experiment. That means it's like this may experiment to be done very perfectly without less errors. That means more accurately me experiment what things that you need to follow. That's what we're going to talk here, right? Let's quickly right after this, after your calculation, you can write them all directly. Starting from this one, right? Quickly start it. When conducting this experiment, when conducting this experiment, heat produced during the reaction, heat produced during the reaction, heat produced during the reaction, when conducting this experiment, heat produced during the reaction should not be lost to the environment. Should not be lost to the environment. Heat produced during the reaction should not be lost to the environment. To obtain final temperature of the reaction accurately, to obtain final temperature of the reaction accurately, to obtain the final temperature of the reaction accurately. Therefore, the reaction has to be performed. Therefore, the reaction has to be performed. Therefore, the reaction has to be performed in a well thermal insulated reaction chamber. In a well thermal insulated reaction chamber. Okay. So the next thing that you have to know is this, right? Now, though we add, listen, though we add HCl and NaOH, though we add these two, like we add them as a bulk, right? If you can understand, we add them as a bulk, like that means we add the HCl 50 centimeter cubes of a volume, and then we add sodium hydroxide 50 centimeter cubes of a volume, right? We add them as a bulk, right? So though we are adding them as a bulk, the thing what you have to know is these molecules, each molecule has to react each other to give you a product. Okay, right? Though we add them as a bulk, each molecule has to meet each other and react each other to give you the product. Products include heat as well, because if you can remember, during this reaction, heat was evolved out. So for this reaction to happen, each molecule of sodium hydroxide and HCl has to meet each other. Then only the products will be formed, including the heat. So You can't assume all of the molecules once you add them together, each molecule will meet with each HCl molecule. It's like this. Each HCl molecule will meet all the sodium hydroxide molecule at once and start getting reacted. No, it will not happen again. Molecules meet when and each other and they will not be reacting together at once. So then what do we have to do? We have to make them meet each other very rapidly. So for that, once you add the two solutions, you need to start them stirring. So then only the things will be like getting mixed well, and then the molecules will meet up each other. So then they will produce the products very soon, and then you can reach the final temperature also very, very soon. Otherwise, until every molecule meets each other and reacts and finishes the reaction, you have to wait to get the final temperature. So what we have to do once you are added with these chemicals, suddenly you have to start stirring to give them a good mix to make the molecules meet each other to finish out the reaction. So then the final temperature of the reaction can be easily and quickly be read, right? So the next step is that, so to make them meet each other, you're stirring the solution very well once the chemicals are added. That makes you comfortable to get the final temperature of the reaction very quickly, right? Otherwise, you'll have to wait for a long period of time until every HCl molecule meet with every other NaOH molecule to finish up the reactions, right? So write like this. Next point, to obtain a uniform final temperature of the reaction, to obtain a uniform final temperature of the reaction, to obtain a uniform final temperature of the reaction, to obtain a uniform final temperature of the reaction, the mixture has to be stirred well. The mixture has to be stirred well. The mixture has to be stirred well once the reactants are added. The mixture has to be stirred well once the reactants are added. The mixture has to be stirred well once the reactants are added. Okay, the next thing, when this stirring is done, okay, right, when you, now you have to stir it, right? So the thing what you can understand from here is once you are added with this reactants, now it's anyway a sealed type of container. If you can remember, you have to add a stirrer. If you can remember, we use the stirrer, we inserted a stirrer to this reaction chamber. We have to stir it, okay? Now the stirrer, can you remember? The stirrer what we used here was a glass rod, right? Or it could be a wooden rod, right? You cannot use the thermal conductive material over here. Now, usually for acid reactions, for any reaction which is related with acids, you don't use metals because metals could be corroded by acids. Acids are in metals, so we commonly don't use metals for this sort of acid reactions which are related with acids. In case if you use the metal, what would happen? Through the metal, the reaction heat will be conducted into the external environment. Main metal through heat generate heat will conduct into the external environment. So it will generate with the final real temperature thermometer read right? Make a generate a reaction generate a real final temperature thermometer read through your stirrer the heat has transferred to the external environment. So make sure your stirrer has to be an insulating material for heat, right? So write the point. Has to be stirred immediately after the reactants are added. And the stirrer should be made from a material sorry, don't write long sentences. Let's simply write it. So the stirrer has to be a thermal insulating material. The stirrer has to be a thermal insulating material. That's fine. The stirrer has to be a thermal insulating material. Within brackets, you can write glass or plastic. Now you might be wondering, like, okay, doesn't plastic get dissolved with acids? No, right? No, right? Most of the concentrated acids are also sometimes stored in plastic containers, right? So I will be showing you those things when we come to like uh, acid base neutralization reaction. We have a lesson called acids and bases. I'm planning to have another seminar for that. Most probably in this month, 24th, I'm planning, right? I'll just inform it accurately to you if you're like waiting to visit, right? Usually acids are stored in these plastic containers because you can't store them in metal containers. Metal conductor containers will get dissolved due to acids. Glass containers you can't import them and transport them acids, right? Because they are easily fragile, so they can easily get fragile. So then we commonly use plastic containers for the transportation of acids, right? So you can either use a plastic rod as the stirrer or a glass rod, right? Okay, right, like this. The stirrer has to be a thermal insulating material. Okay, that's it. Then you can write. Okay. Now, what you have to understand from here is when you add when you add 50 centimeter cubes of 2 moles per decimeter cube of HCl with 50 centimeter cubes of 2 moles per decimeter cube of NaOH, you observed a reaction of generating a salt. That salt is NaCl basically, and then water haduna metala. And then we also observed heat was generated. Okay, how much of heat was generated through this reaction? 4,200 joules of heat was generated. Okay, 4,200 of 4,200 joules of heat generated during this reaction. Right? Then what case you should know, like, now if you are okay with this concentration, when you are given with a volume and a concentration, you know how could you find out how many number of moles of HCl and how much of a number of moles of NaOH got reacted in this experiment to produce you 4,200 joules of energy. Okay, the main reaction what really happened? Some number of moles reacted with some number of moles of HCl to produce you 4,200 joules of energy. And now I'm asking you to find out how many moles of HCl got reacted with how many moles of NaOH to give you 4,000 joules of heat energy. So write this point. The above experiment gives you the amount of heat. The above experiment gives you the amount of heat evolved when some amount of moles of HCl got reacted with some amount of moles of NaOH. Okay, then write the question. Find the number of moles of HCl. Write the question. Find the number of moles of HCl. Number of moles of HCl and NaOH got reacted in the above experiment. Find the number of moles of NaOH and HCl reacted in the above reaction? You got to find it out. Find the number of moles of HCl and NaOH got reacted in the above reaction. Okay, this is how you calculate the number of moles of HCl got reacted with number of moles of sodium hydroxide in the reaction in the experiment that we conducted. Right. Did you find it? Okay. හරිද ළමයි? ඉවරද? තාම කවුරු හරි කරනවා නම් අත උස්සන්න පොඩ්ඩක්. සුසෑන් හරිද? උපේ හරිද? උපේ, were you able to do the calculation or you did after?
Yes, I did. No, I didn't.
Good. Right, okay. So then, is everyone done with the calculation? Shall I go on? Shall I move on?
Yes, sir.
Okay, perfect. So that means you can understand when I have this amount of HCl, this volume of HCl with a concentration of 2 moles per decimeter cube, that means I've added 0.1 mole of HCl with 0.1 mole of sodium hydroxide. So when 0.1 moles of sodium hydroxide reacted with 0.1 moles of NaOH, 4,200 joules of heat energy was produced. Okay, my next question, right? The next question. If 1 mole of HCl, if 1 mole of HCl reacted with 1 mole of NaOH, if 1 moles of HCl reacted with 1 moles of HCl in the above experiment, find the amount of heat generates. Find the amount of heat generates. Okay, now in our reaction, we reacted 0.1 moles of NaOH molecules with 0.1 moles of HCl molecules. So I'm asking if 1 mole of HCl got reacted with 1 mole of NaOH, how much of heat could be generated, right? In the same experiment, same way, nothing is different. Only thing is the amount of reactant you're going to add is higher than the amount that you've already added. Simple, right? Think and then get the answers. I'll give you like 1 minute. Anybody comes up with an idea, just can raise up the hand, right? Quickly. Anybody with an idea? It's very simple, guys. Listen, see here. Then ඔයගොල්ලන්ට මෙතන පේනවා නේද, when I react 0.1 moles of HCl with 0.1 moles of NaOH, 4,200 joules of heat is released. So මේ reaction එකේම what am I asking you to do? I'm asking you to make it react with 1 moles of HCl with 1 moles of NaOH. Okay, then I'm asking how much of heat could be generated. That's what I'm asking, right? Now, can you think the relationship between 0.1 mole and 1 mole? 0.1 mole වගේ 10 times නේද ළමයි 1 mole කියන්නේ. මෙතනත් 0.1 moles වගේ 10 times නේද 1 mole කියන්නේ. ඒ කියන්නේ කලින් දාපු reactant amount වලට වඩා 10 times reactants මම දාලා. Same reaction එකේ කලින් දාපු reactant amount එකට වඩා 10 times reactants මම දාලා. එහෙනම් ළමයි generate වෙන heat එකත් කලින්ට වඩා key times ද 10 times. It's very simple. පට්ට simple. පොඩ්ඩක් හිතන්න විතරයි තියෙන්නේ, right? So කලින් reaction එක වගේ 10 times reactants මම දාලා දැන් මම කියන්නේ දැන් what it would happen if 1 mole of HCl reacts with 1 mole of NaOH කියලානේ. කලින් reaction එකේ 0.1 moles of HCl නේ 0.1 moles of NaOH එක react කරලා තියෙන්නේ. So I'm asking what would happen if you add the reactants 10 times greater than the previous situation. So what would happen? The generation of heat will be also 10 times greater than before. So here 42,000 joules of heat energy is going to be generated. Okay, simply 42,000 joules of heat, right? Right, that's what's simply going to happen, right? So 42,000 joules of heat is going to generate, and then you can convert into 42 kilojoules. එච්චරයි වෙන්නේ. වෙන මොකුත් අමුතු දේවල් වෙන්නේ නැහැ. ඔයාලට කරන්න බැරි calculation එකක් නෙමෙයි. Do the calculations very quickly. Right. ඒක තේරුණාද බින්සෙන්? හරි සිම්පල් කතන්දරයක්. තේරුණාද? බින්සෙන් ඒක තේරුණාද? Right, okay. Emily එක clear. So what you have observed here is an exothermic reaction. What did we do? We have actually used, I think I'll have to write it again. We have actually used two aqueous solutions for this reaction. I'll just write it again for you to see. See here, I actually added here HCl aqueous, okay, and then I added NaOH, okay, that was also aqueous, all right. And then what was produced here? NaCl aqueous was produced, and water was produced as a liquid, and then heat was produced. Heat was produced. Okay. Heat was produced. This is what happened, right? Okay. So guys, now for this reaction, I had to use volume of 50 centimeter cube of HCl with a concentration of 2 moles per decimeter cube. That's what I did, no, right? That's what I did. I used 50 centimeter cubes of HCl with a concentration of 2 moles per decimeter cube. Same concentration, same volume of NaOH was also used. And then when they got reacted, I obtained heat of 4,200 joules. I obtained the amount of heat released to the external environment as 4,200 of joules. Now the thing is, you can clearly see I have added 2 aqueous reactants. Now, if you can't, I just caught up with a person in the class who joined the class later, and that person was not aware what an aqueous solution is. So then I hope you might also have some problems of memory, and then I'll just quickly revise what an aqueous solution is. Okay, so like if you had salt, we call it as a NaCl solid. If I dissolve it in liquid water, okay, if I dissolve it in liquid water, what solution I would get? A salt solution. I would get a salt solution. So for that I can call aqueous salt aqueous solution, aqueous salt solution. So what I have done here, I have a solute here in the form of solid. I dissolve that in liquid water to make a solution. I call that solution as an aqueous solution. So then I'm telling you, you know ethyl alcohol, right? So I take ethyl alcohol. So ethyl alcohol comes as a liquid, okay? And then I dissolve it in water. Then I form ethyl alcohol. I form ethyl alcohol solution, okay? That can also be called as aqueous. So any solute, liquid or solid, when it dissolves in water, you call it as an aqueous solution. So you know the condition, something to be called as a solution, for a mixture to be called as a solution, the mixture has to be a homogeneous mixture. The mixture has to be a homogeneous mixture, right? So then if you make a homogeneous mixture, which means a solution, by dissolving any kind of solute, the solute can be in the physical state of a solid or a liquid. If you dissolve that thing in a solvent like water, not like the insolvent water, the solutions made are called aqueous solution. Okay, so here what did we do? I took aqueous HCl. That means this HCl, now you can't take it's 100% HCl. Keep it in your mind. 100% HCl is a vapor, right? Vapor means a gas. So that means that ඔයාලා හිතනවා 100% HCl ගන්න පුළුවන් කියලා 100% HCl ගන්න බෑ, right? It's a vapor and it does not show any acidic characters as well. So what do? you take HCl vapor, which is 100%, and then you dissolve it in water. Okay, then only it becomes HCl aqueous. හැබැයි දැන් මෙයාගේ concentration එක අඩුයි, dilute වෙලා තියෙන්නේ 100% නෙමෙයි HCl. Now it's mixed with water. Now only it behaves as an acid. So until then, when it was a vapor, it was actually neutral, right? When it is a vapor, it's neutral. When you dissolve HCl in water, only it starts to show its acidic property. So you cannot obtain HCl in the lab in the form of a liquid. That means a liquid can 100% HCl liquid විතරයි තියෙන්නේ. Water එහෙම හම්බෙන්නේ නැහැ ඔයාලට. Right? You would obtain HCl in the form of an aqueous mixture. Aqueous solution එකක් හම්බෙන්නේ. කොහොමද එයාව හදලා තියෙන්නේ? HCl vapor එක dissolve කරලා HCl vapor එක dissolve කරලා in water. That's how it's made, right? The next, so then for this reaction you have no option. අනිවාර්යෙන්ම ඔයාට HCl නම් add කරන්න වෙන්නේ aqueous එකක් විදියට තමයි. You have no any other option. HCl you have to add it as an aqueous solution. එහෙනම් ඔයාට point, now if you can remember from HCl we actually added 0.1 moles, right? We actually added 0.1 moles of HCl. So if you want to add 0.1 moles of HCl, ඔයාට මොනවද කරන්න වෙන්නේ? You have to take the concentration of HCl and then a concentration එකකින් 0.1 moles of HCl ගන්න කොච්චර volume එකක් ගන්න ඕනද කියලා N equals CV equation එක දාලා calculate කරගන්නවා. Calculate කරලා ඒ concentration එක තියෙන ඒ volume එක තියෙන එක තමයි අරගෙන තියෙන්නේ. Right. But when it comes to sodium hydroxide, you have two options actually. Okay, you have two options. One, you can take NaOH in the form of aqueous. ඒ කියන්නේ NaOH තියෙනවා lab එකේ aqueous solution එකක් විදිහට. So from the aqueous NaOH, if you use this N equals CV equation and what මෙතන දාගන්න ඕන 0.1 moles of NaOH නේ. එතකොට මේ concentration එකෙන් කොච්චර volume එකක් NaOH ඕන වෙයිද 0.1 moles ගන්න කියලා calculate කරගෙන මේ volume එක ගන්න පුළුවන්. Or else you can take NaOH pellets, right? So I'm telling you, you can completely add NaOH not as a liquid here, not as an aqueous form here, but as crystals. Sodium hydroxide pellets lab එකේ තියෙනවා, right? So sodium hydroxide 1.1 moles වලට දාන්න පුළුවන් aqueous mixture එකක් විදිහට නැතුව උනත් pellets. Okay, so then now what you're going to do, now if you are adding it as pellets, right? If you are adding it as pellets, now what is your basic idea? You want to add 0.1 moles of HCl or NaOH, 0.1 moles of NaOH. දැන් මම add කරන්න යන්නේ NaOH කියන aqueous form එක නෙමෙයි. I'm not going to add NaOH aqueous, right? I'm not going to add NaOH aqueous. I'm going to add NaOH solid. Solid එක දාන්න යන්නේ, right? Solid දාන්න. Pellets දාන්න යන්නේ. හැබැයි මම දාන්න I have to make sure 0.1 moles of NaOH දාන්න ඕනේ. එහෙනම් I have to calculate when I put how much of a mass of NaOH 0.1 moles will be added. එහෙනම් ඒක calculate කරගන්න I can use N equals M over M equation. Okay, so how many moles I need? 0.1 moles. I know it, right? So molar mass of NaOH I can simply calculate. I can calculate molar mass of NaOH. How to do that? Sodium hydroxide NaOH, relative atomic mass of sodium is 23, relative atomic mass of oxygen is 16, relative atomic mass of hydrogen is 1. So altogether it becomes 40 g mole minus 1, right? Relative atomic molar mass of NaOH is 40 g mole minus 1. So when I multiplied the number of moles I required with the molar mass of NaOH, I would get the mass what I need to take to obtain that particular amount of moles. Here moles here 0.1 moles. Okay, liwa. Molar mass here sodium hydroxide 40 g mole minus 1. Okay, all right. Here plus mole minus mole 40 into 0.1 4 grams. So lamai ඔයාට පුළුවන් sodium hydroxide 8 centimeter cubes දාන්න නැතුව with a concentration of 2 moles per decimeter cubes may 0.1 moles per දාගන්න ඕන නම් you can put sodium hydroxide crystals also, but you have to calculate how much of mass of sodium hydroxide you need to add here. How to do that? Using the N equals MOM equation, then you would come up with 4 grams. That means if you put 4 grams of NaOH, again sodium hydroxide crystal weighs 4 grams, then mixture you're adding the same number of moles that you added sodium hydroxide into this reaction from aqueous. Right, aqueous medium making damma amount එකම sodium hydroxide වලට දාන්න පුළුවන් sodium hydroxide solid crystals grams 4ක් දාන්න. Right, so that option is only available for sodium hydroxide because sodium hydroxide can be taken in the both form, solid crystal form and the aqueous form. So එතකොට එයා crystal form එකේ ඉන්නකොට basic කොහොමද, right? But HCl does not come in solid form, right? It comes only in the aqueous form. එතකොට එයාට එහෙම option නැහැ. Sodium hydroxide වලට අපිට option එකක් තියෙනවා. We can add sodium hydroxide in the form of solid, right? So write like this. So I මේ කතාව තේරුණාද කියලා කියන්න මට පොඩ්ඩක්. දැන් මම මොකද කරේ ඉස්සෙල්ලා මෙතන දාලා තිබේ sodium hydroxide in the form of aqueous. දැන් මම මොකද try කරන්නේ මෙතෙන්ද sodium hydroxide aqueous දාන්න නැතුව sodium hydroxide solid form එකෙන් දාන්න හදන්න. So solid form එකෙන් දැම්මත් මම කොච්චර sodium hydroxide දාන්නද 0.1 moles. ඒ කලින් aqueous දැම්මම 0.1 moles sodium hydroxide වැටුනේ. දැන් මෙතනනොත් 0.1 moles sodium hydroxide තමයි දාන්න ඕනේ. So what should I do here? මම calculate කරගන්න ඕන 0.1 moles sodium hydroxide solid වලින් ගන්නව නම් කොච්චර sodium hydroxide mass එකක් මෙතන දාන්න ඕනද? How to do that calculation? යාරගේ volume එකකින් කොච්චර number of moles හොයන්නේ මේ equation එකකින් වගේ mass එකක් කොච්චර mass එකක් sodium hydroxide දාන්න ඕනද 0.1 moles ගන්න කියලා අපි හොයන්නේ මේ equation එකේ. N equals MOM එකේ. So අපි number of moles required here දන්නවා and sodium hydroxide වල mole mass එක මෙහෙම calculate කරගන්න පුළුවන්, right? එතකොට අපිට එනවා number of moles වලින් mole mass of sodium hydroxide වැඩි කරපුවම sodium hydroxide mass එක එනවා. ඒ කියන්නේ ඔයාට 0.1 moles ගන්න ඕන නම් sodium hydroxide මෙතෙන්ට solid crystals වලින් ඔයා දාන්න ඕන gram 4ක් sodium hydroxide. මේ කරපු වැඩේ තේරුණ කට්ටිය පොඩ්ඩක් මට අත උස්සන්න. Was it clear to you, Bimsen? Emily එක clearද? Ellie එක clearද? අමාරු දෙයක් කරපු එක. Hold on. I will give this to you, right, like this. If you hold on, right, like this. For the same reaction, instead of adding 0.1 moles of sodium hydroxide, for the same reaction, instead of adding 0.1 moles of sodium hydroxide, in the form of an aqueous solution, you can add okay, so in the same reaction, instead of adding 0.1 moles of sodium hydroxide in the form of aqueous solution, you can add sodium hydroxide. Crystals in solid form. You can add sodium hydroxide crystals in aqueous form. Okay. Okay. The amount of, next one, the amount of solid sodium hydroxide needed, the amount of solid sodium hydroxide needed, the amount of solid sodium hydroxide needed, the amount of solid sodium hydroxide needed to add 0.1 moles of sodium hydroxide, to add 0.1 moles of sodium hydroxide can be calculated as below. Can be calculated as below. Okay. Can be calculated as below. Right, done. ඉවරද ළමයි? කට්ටිය ඉවරද? කොහොමයි ළමයි රෙස්පොන්ස් කරන්නේ නැහනේ. කට්ටිය ඉවරද?
ඉවරයි සර්.
Right, okay. Ko me upe Elisha ko Shanoki.
Done sir.
Done, sir.
Okay, okay. Upe.
Done, sir.
Right, okay. Right. Hari. Then lamai what would happen? What would happen? Then මෙහෙමයි වැඩේ. Then the scene is මෙහෙමයි. Then අපි දැක්කා in the earlier situation, shall we delete this one and this one also? Okay. Yeah, this one also. Let's keep it. Right, okay. May situation we observed like where 0.1 moles of aqueous HCl, aqueous HCl, when reacted with 0.1 moles of aqueous NaOH, කොච්චර heat එකක් ආවොත් 4200 joules heat ආවා. දැන් මොකද කරන්නේ? දැන් reaction එකේ මොකද මම කරන්නේ? I am reacting 0.1 moles of HCl in aqueous form and still 0.1 gram 4ක් solid වලින් දැම්මට තාමත් NaOH දාලා තියෙන්නේ 0.1 moles. 0.1 moles of sodium hydroxide in solid form. Finally බැලුවොත් මෙයාගෙනුත් 0.1 මෙයාගෙනුත් 0.1 react වෙලා තියෙනවා. يعني කලින් එකේ වගේමයි. කලින් එකෙත් මෙයාගේ 0.1 මෙයාගේ 0.1 react වුණේ. මෙයාගින් reactants 0.1 මෙයාගින් reactants 0.1 react වුණාම 4200 joules තමයි heat generate වුනේ. දැනුත් මොකද වෙලා තියෙන්නේ? මෙයාව තාමත් මම reactance දාපු amount එක වෙනස් කරලා නැහැ. මෙයාගෙනුත් moles 0.1 මෙයාගෙනුත් moles 0.1. only thing is මෙයාව කලින් දාලා තිබ්බ aqueous form එකෙන් දැන් මම දාලා තියෙන solid form එකේ. now you would think ඉස්සලා දාපු amount එකත් එක්ක ඉස්සලා දාපු sodium hydroxide moles ගානම තාම තියෙනවා reaction එකේ. එහෙනම් reactance වැඩි වෙලාවක් අඩු වෙලාවක් නෑනේ. එහෙනම් මෙතන ජෙනරේට් වෙන හීට් එක තාම කීයක් වෙන්න ඕනද? 4200 joules වෙන්න ඕන කියලා ඔයගොල්ලෝ හිතනවා. හැබැයි එහෙම නෑ. right? ඇත්තටම මෙතන ජෙනරේට් වෙන හීට් amount එක දැන් 4200 නෙමෙයි, it's a different one. Why? The reason is we are මෙතෙන්ට 0.1 moles of sodium hydroxide දැම්මට the physical state එක වෙනස් වුණාම මේ heat exchanging reaction වල evolve වෙන නැත්නම් generate වෙන heat amount එක වෙනස් වෙනවා. දැන් හිතන්නකෝ ඒක සාමාන්‍යයෙන් ඒගොල්ලන් advanced levels වලට කියලා දෙන ඔය dissociation වන වලට එහෙම energy යනවා කියලා. හරිද? right? Simply keep it in your mind. මේ වගේ reaction එකක් perform වෙනකොට ඔයා දැන් මට මෙතන මෙච්චරයි කියලා දෙන්න ඕනේ. දැන් මෙතන මම variate කරේ නෑ කිසිම වෙලාවක දාපු reactance amount එක. ඉස්සල්ලා HCl 0.1 moles දැනුත් NaOH 0.1 moles තමයි. Habai, the only thing that I changed here was the physical state of sodium hydroxide added into this reaction. Istalla sodium hydroxide mama add kare in the form of aqueous, then sodium hydroxide add kare solid form में. Habai 0.1 में तमाई. उगलां assume करना इस्सरा amount of reactants of sodium hydroxide में मेतना तीन ही इंदा थामत 4200 joules of heat produce वे किरा नया हिम वे नया දැන් මෙතන ජෙනරේට් වෙන හීට් amount එක ඇත්තටම වෙනස් වැලියු එකක්. සමහරලාට 4200 joules වලට වඩා හීට් එක අඩුයි. right 4200 joules වලට වඩා හීට් එක අඩුවෙන් ජෙනරේට් වෙන්නේ. ඇයි මෙතන හීට් some amount of heat use වෙනවා මේ sodium hydroxide crystal එක පොඩ්ඩක් dissolve වෙලා අරයත් එක්ක react වෙන වැඩේට. right එතකොට තමයි what you have to understand the lesson, the learning part of this reaction, this concept is we are heat related heat exchanges ගැන chemical reactions ලියනවා නම් don't ever forget to mention the physical state of the reactants. So write the point. Even the same amount of NaOH was added into the reaction. Even the same amount of NaOH was added into the reaction. Even the same amount of NaOH was added into the reaction in the form of solid. Now the heat exchange resulted during the reaction. Is different. This is because we added sodium hydroxide. This is because we added sodium hydroxide in the form of solid. Special panic in liya gana atau panicking wage liya gana. Therefore, when indicating chemical reactions about heat exchanges, the physical states of the reactants should be necessarily indicated. should indicate them. අනිවාර්යෙන් indicate කරන්න ඕනේ. You have to indicate them, right? ඒ කියන්නේ ළමයි then in the early situation, right? Early situation, method of 0.1 moles of aqueous, 0.1 moles of aqueous sodium hydroxide react කරන 4200 joules. හැබැයි මෙතන දැන් අපි කරේ 0.1 moles of aqueous equivalent 0.1 moles of solid in which amount of heat release එක වෙනස්. ඒ කියන්නේ ඔයාට අමතකුණොත් මෙයාගේ physical state එක mention කරන අතන produce වෙන heat amount එක වෙනස් වෙනවා. එහෙනම් ඔයා වැරදි. That means මොකක් හරි physical state මොකක් හරි endothermic හරි exothermic එකක් හරි heat changes associate වෙන chemical reaction එකක් ලියනවා නම් don't ever forget to write the chemical reactions with the physical state of the reactants. එහෙනම් දැන් ඔය පොඩි point එකෙන් ඔයාලට ලකුණු ගොඩක් මිස් වෙන්න පුළුවන්. දැන් ඔය දෙන්නේ theory එකක්. right concept එකක් දෙන්නේ. ඕක relate කරලා questions දැන් ඕක හරි පොඩි point එකක් නෙමෙයි lesson එකේ මාර important point එකක්. හැබැයි ඒකට පොඩි point එකක්. එක තරක තිබ්බේ. ඕක relate කරලා ඒගොල්ලන්ට MCQs හදන්න පුළුවන්. ඕක relate කරලා ඒගොල්ලන්ට structure essays දාලා questions දාලා වඩ වරද්දවන්න පුළුවන්. ඇයි ඔය චූටි කැල්ල මතක නැත්නම් ඔයා හිතනවානේ same amount of reactors react වුණාම physical state එක වෙනස් වුණොත් අතරින් generate වෙන එකම heat එක කරන එහෙම නෑ ඒක වෙනස් වෙනවා. So make sure that you study it and keep it in your mind very firmly. ඒක මාර ටිකක් weight එකක් තියෙන learning point එකක් මෙතන. මොකද ඒගොල්ලන්ට MCQs වලට එහෙම true or false දානකොට එහෙම අනිවාර්යෙන් include කරන්න පුළුවන් point එකක් හරි easily ඔයාව වරද්දන්න. හරිනේ? Right. Okay. So that's it for today guys. We are done with the lesson, right?